Welcome to this Ginan tutorial on downloading and installing Ginan, which will support you using Ginan, Geoscience Australia's GNSS Processing Toolkit. I'm Ron, and I'm from the GNSS Analysis team. I'm the operations lead and use Ginan for my research. Ginan was developed as part of the Positioning Australia program. You can read more about Positioning Australia on the Geoscience Australia website, www.ga.gov.au. This tutorial is one of a series of tutorials which cover how to find, download, build, install, and use Ginan. In this video, I'll be showing you how to download and install Ginan to a local machine. To showcase these steps, I'll be using a fresh Amazon EC2 instance running through the Amazon Cloud9 IDE, which is what you see on screen right now. But these steps can be carried out on any Ubuntu machine you have available that is running at least Ubuntu 18. Firstly, please ensure you have at least 40 GB or more of free disk space on your machine for Ginan and its dependencies. We can see that on this machine here, we have over 180 GB free disk space, so that's plenty. You can find the source code for Ginan at github.com/geoscienceaustralia/Ginan, as seen on screen. Before cloning the repository, please ensure that you have Git and a number of base dependencies installed. You can find the commands on how to do this on this README. If we scroll down to dependencies, you can see that there are instructions on how to install with Ubuntu. So we'll just go ahead and copy these in. We now have the base dependencies installed. Ginan also relies upon a number of libraries to run, namely YAML, Boost, Eigen3, and netcdf4. Ginan uses YAML to parse our configuration files, Boost for a number of utilities including time and logging libraries, Eigen3 for efficient matrix calculations, and netcdf4 for our ocean tide loading module. To install these, we can create a directory to house the installation files. What we can do is just make a directory called temp. We'll be placing all our files into here. We will start with YAML, and after moving directory, we can just copy out all these commands. Now that YAML is installed, we can move on to installing Boost. Again, we'll just copy out the commands as they are in the README, and Boost will be installed. We do the same to install Eigen3 by copying out these commands. An optional installation that can be used with Ginan is MongoDB. MongoDB is useful for creating and investigating large amounts of processed data. We will not go through this here, but the README on the GitHub also contains instructions on how to install this for a Linux machine. The last package, netcdf4, can be installed by, again, copying out the installation command and running in the terminal. Now that the dependencies are all installed, we can clone the repository by scrolling up, copying out this address, going back to our terminal, and git cloning to the directory we desire. Here, we will go back to the environment directory and enter git clone followed by the address we copied. So now that we have the source code, we can move on to building the software. To do this, we change to the Ginan directory, and within that directory, you'll see another directory called src, or source. Within there, we will make a new directory called build and enter it. Then we'll use the following commands. Referencing the README, we can see there is a cmake command that we will be using. Now, if you installed MongoDB as part of your dependency installation, you'll need to include a flag called denable MongoDB and set it to true. You can also use an optimization flag. Although not necessary, it is advised to compile an optimized version of Ginan. So we'll copy this and use what we need here. As we didn't install MongoDB earlier, we'll just use the optimization flag. Having run cmake, we now have the makefiles necessary to build the binaries using the make command. You can include the number of parallel threads you want to use for the compilation by using the -j flag. In this case, we'll use 4. Once this is finished running, Ginan is ready to use. We can now check the primary modules of Ginan by calling their help docs. The two main modules of Ginan are the pod, or the precise orbit determination module, and the P, or the parameter estimation algorithm module. To test the pod, we write the following command and see that the help docs appear, which briefly explain how to use it. This verifies that the pod has been installed correctly. Now, typing in the next command tests the P. Again, we get the help message showing us how to use the P and the various options available. This verifies that the P has been installed correctly, and therefore that Ginan has been successfully installed as well. This is the end of the video. Please watch the next video in this series to learn about the various examples that can be run to show the many capabilities of the Ginan software. Thank you.